Hello everybody, Radu here from Infinet Wireless. Thank you very much for joining me. Today we have the last Infinet Wireless webinar of this year, and we decided to show you some interesting tips and tricks that will help you deploy your Infinet devices more quickly and also overcome some difficult situations that might appear in the field. As always, we will have a Q&A session in the end, but if you have any questions during the webinar, please feel free to write them down in the chat section at any time. So, without further introductions, let's begin. The first trick that I want to show you is related to the standard mounting kit of the Infinet Wireless devices. Normally, it is suited for poles between 30 and 85 millimeters in diameter, but what do you do when you only have a thinner pole available on site? Well, if you simply rotate the bracket of the mounting kit and put it the other way around, like you can see in this picture, you will be able to solve the problem quickly and easily without having to install a bigger pole or to use some kind of spacer between the pole and the bracket. Next, I want to show you how you can remotely change the username and password for a CPE. For example, if a technician misspells the password during the initial configuration of the CPE, making the unit inaccessible, you can reconfigure the password from the base station by using the remote commands feature. Of course, the link between the base station and the CPE must be previously established, and then you must simply click on the link in the device status window, choose remote commands, and enter the command for creating a new username and password for the CPE. That's all you have to do. The commands are sent over the proprietary Mint set of protocols, and no additional authentication is needed. Just the link itself is required. Moving on to some useful third-party devices that can allow the technicians to configure the Infinet Wireless devices more easily. And first, we have this very interesting Powerbank, which can provide power over Ethernet and also has an integrated Wi-Fi access point. Thus, it can be used to temporarily power up an Infinet Wireless unit and also to connect to it using your smartphone. This can be very useful in situations like when one technician performs the antenna alignment while another one prepares the cabling. During the site survey, it allows the technicians to temporarily install and configure the units without using power supplies and laptops. And in case of problems, it can help you to quickly check whether the radio device is dead or there are issues with the cable, the PoE, and so on. You can also create your own PoE power bank by using a DC injector like the IDU CPE DC and a small battery pack, like you can see in this picture. If you prefer to buy it, this is an example of a PoE power bank with Wi-Fi available for online order. It works similarly with the one that I showed you a bit earlier. If you don't necessarily need Wi-Fi, you can choose one of these two types of power banks. You will need to use a laptop to connect to the radio device, but at least you won't have to worry about the power supply. And for more intense work or for video surveillance projects, you can use the next device that you can see in the bottom part of the slide, which is a battery-powered PoE injector with a wireless network link, designed to also help you install IP cameras because it can stream live video to smartphones, tablets, and laptops. Next, I will show you another interesting trick. Let's say, for example, that you have a lot of Infinet units to configure and you connect to them using a switch. At some point, you might forget which device you are configuring. So, to reveal the connected Infinet unit, all you have to do is input the syssearch command in the CLI, and the LEDs on the back of the device will start blinking for 10 seconds. This way, you will know exactly to which unit you are connected. In some situations, you might not want to keep the LED panel visible. So in such cases, you can easily switch off all LEDs using the sys no indicator command. As you can see in this animation, the LEDs have been turned off, But don't worry, the unit is still working normally. If you input the sysindicator command, the LEDs will turn back on. Moving on to some antenna alignment tips. First, a very important practice that you should keep in mind when building long-distance links is to set the bandwidth and bitrate to the minimum values during the alignment procedure. This means that you will benefit of the highest sensitivity that the radio is capable of, allowing you to establish a link more quickly. Of course, the output power should be set to the maximum value, bearing in mind the EIRP limitations in your region. After the alignment has been completed, the bandwidth, bitrate, and power can be optimized to meet the performance requirements for the link. Another small trick: if the technicians don't have compasses or cannot estimate the azimuth and elevation by which to aim their antennas, they can use mirrors to signal their target locations. Or they can also use other tools like laser pointers, for example. In some non-line of sight situations, you can use reflections from nearby buildings, especially the ones with glass walls, to create links between your devices. Of course, the link performance will be much lower compared to a clear line of sight situation, but when you have no other option, this technique offers you a good chance to create at least a decent connection between your points of interest. Now, let's talk about some powering options for the Infinet devices. As I mentioned in one of our previous webinars, not all Infinet Wireless units are compatible with the .380 standard. The Infilink 2x2 Lite devices and the CPEs only support passive PoE. So when you need to power them, not by using the standard included power supplies, but with different sources like PoE switches, for example, you must use devices that support passive PoE, like the ones shown in the bottom part of this slide. The standard PoE switches will not work with the Infilink 2x2 Lite and the Infiman 2x2 CPEs. Let's look at an example. Say you want to power up both an Infilink 2x2 unit and an IP camera using a standard PoE switch that only supports the .380 or AF standard. In this case, as you can see in this diagram, you must use an 802.3 to passive PoE converter between the switch and the Infilink 2x2 unit to be able to power it. And of course, if you only need to power an additional device besides the Infinet Wireless unit, like an IP camera for example, you can also use the PoE out feature that is supported by the type of SMN devices that have two Ethernet ports. The standard power supply unit that comes with the SMN outputs 48 volts, so if your camera supports this voltage, it can be powered through the second Ethernet port of the Infinet Wireless unit, eliminating the need for a second power supply or a PoE switch. And the last trick that I want to show you today is how you can make a wireless connection over an obstacle, like a hill for example, using the Infinet Wireless devices. Usually in a situation like this, the standard solution is to install 2 additional wireless units at the top of the hill, but if you don't need full capacity, it is possible to add just 1 connectorized unit as well, with 2 external antennas. The solution involves configuring the relay unit from the top of the hill and the hidden CPE as mesh. The relay unit will work in MISO mode and will use 2 external antennas, each with a different polarization, to communicate with the master and the hidden CPE. The master and the slave units will work in MISO mode, while the CPE must be configured as CISO. Of course, this solution can have a big disadvantage if you need high capacity for the hidden CPE. By using the mesh mode, polling becomes unavailable, so a classic CSMA-CA algorithm will be used for the communication between the master, roaming leader, and roaming enable units. Because the master and the roaming enable, which is the hidden CPE, do not have visibility of each other, they cannot sense each other's transmission, so the scenario suffers from the hidden node issue. The behavior in the field can be unpredictable depending on distances, signal levels, and so on. You could be limited to throughputs of up to 15% of the estimated bandwidth. Therefore, we recommend you to first test the solution, and if the results are not satisfactory, simply use 2 relay devices at the top of the hill. Right, so this brings us to the end. Thank you all once again. Happy holidays everyone, and see you next time.